Okay, Math 2 students, here we go on the Unit 8 practice test. Number 1 is just getting you to test your vocabulary. So minor arc of A would be BC. The radius of Z, there are a couple possibilities, but ZX would be one of them. VZ would be the other one. Diameter of Z, there's only one of those, VX. A chord of Z. So here's circle Z. The only chord that we show, well, actually we show two. There's VY. That's the chord that is not a diameter, but VX is also a chord because it has endpoints on the circle, even though it's also a diameter. A secant of circle Z would be line VY or line Vx. A secant is defined as a line that passes through a circle, as opposed to a tangent, which would be a tangent is something that passes and touches the circle once. Central angle of Z, circle Z. Actually, there isn't a central angle shown, but if we drew a line like that or a line like that, then we could create central angles. So we could do angle VZU or angle XZY. An inscribed angle of Z would be angle XVY. So an inscribed angle is one where the vertex is on the edge of a circle. A central angle is where the vertex is in the center of the circle. A point of tangency on Z would either be U or W. Those are places where a line that is tangent to the circle touches it. So, and that would mean, as a reminder, that this is a right angle if we drew a straight line from W to the center of the circle Z. All right, in circle Q, find the measure of the following parts. This is just testing your ability to add up angles. So I'm just going to look at these diagrams and fill them out and then fill out my questions. So if this is 100, this must be 80. If this is 55, then this one must be 125, because both of those add up to 180. And then that means my arcs are also equal to those measures. So now I just look and see what I've been given. MQR, measure of angle MQR is 100 plus 80 plus 55. So that's going to be 180 plus 50 is 230, 235 degrees. The measure of angle PQN is 80 degrees. Of RQN is 80 plus 55, so 135 degrees. That's RQN, so that's this one. Arc MN, so now we're going over to this one. This is 73, that means this is 73. That means vertical angles means this is 73, that means this is 73. Now I've got 180 degrees here.
Eli, forward to the conference room, please. Eli, forward to the conference room.
So 180 minus 73 gives me 107. And then I can do the same thing here. So 180 minus 73 minus 81. Whoops, 180 minus 73 minus 81 gives me 26 degrees here. So I filled all those things out. Now I can go back and fill this. This is MN is 73 degrees. RN is, the measure of arc RN is 180 degrees. The measure of arc PM from P to M. Now, PM, if we go from P to M, we either go around the outside or around the inside. Anytime we have just two letters, we assume unless otherwise specified that it's the minor arc. So PM is going to be 81 plus 73, or 154. And RNM is R to N to M. So because it doesn't say just RM, but RNM, that means you have to go around the outside. So this is 73 plus 26 plus 81 plus 73 equals 253. The other thing you could do is you could say, well, if this is 170 degrees, I can take the whole 360 and subtract 107, and that's what you get. Okay. Now, about circles. First one here, we're just asking you to go between arcs and central and inscribed angles. So X is going to be exactly the same because it's the central angle. Y is going to be half of that, 54. The exact value of X and Y in the diagram of circle K below. So here I have two secants, and I have a major arc here and a minor arc here. So the angle is bark larc over 2, bark minus larc over 2. So the first thing I'm going to be able to figure out is what X is, because I've got 360 degrees of the circle. 360 minus 75 minus 121 equals 164. I'm going to double check that again. 360 minus 145 minus 121 minus 75. Yeah, I didn't think that was right. Let's try this one more time just to double check. 360 minus 75 minus 145 minus 121 equals 19. So X is 19 degrees. So that's the measure of this arc. So that's my little arc. So I'm going to say this is going to be big arc minus little arc over 2. Let's try that again. 145 minus 19 whoops, 145 minus 19 equals 126 divided by 2 is 63. So this is a 63. All right. Next one. Similar principle here, but instead of having two secants, we have two tangents, which means that the big arc and the little arc together add up to 360 degrees. So 360 minus 245 equals 115, so X is 115. And we use the same formula. So the measure of angle Y is going to be the big arc minus the little arc, 245 divided by 2. I'm going to be careful in my calculator to do this in the right order. So 245 minus 115 equals, and then divide that by 2, and that gives me 65. Number 6, find the exact value of X and Y in the circle Z. So you can see that the circle Z, this line segment, goes all the way through the circle and crosses the center. That means it's a diameter, which means that this arc is 180 degrees, which means this inscribed angle is 90 degrees. This is a 90-degree angle. A 90-degree angle means that I have a right triangle. So the exact value of Y is going to be the exact value of X is 90 degrees. The exact value of Y is going to be based on the relationships between the angle and the side lengths. So this is what trigonometry is for. So I'm going to say some trig function of Y is equal to the ratio of the side lengths I already know. So from here I've got Y, and I've got the adjacent and the hypotenuse. So I'm going to say cosine of Y is equal to the adjacent 3 over the hypotenuse, square root of 21. So to find Y, I'm going to take the inverse cosine of that, 3 over square root of 21. 3 divided by 21 square root equals inverse cosine. Y equals 49.1. So there we have it. Okay. All right, so that was 6. Here's 7. Find the exact value of x and y in the circle. So here we have 2 chords. So our chord theorem when it comes to angles. I'm going to grab my reference sheet here. So this is why your reference sheet is going to be important. When you have intersecting chords, the angle is going to be equal to the average of the 2 arcs. So x is going to be equal to 64 plus 126 divided by 2. Plus 126 divided by 2. 64 plus 126 equals, divided by 2, is 95. And y is going to be found using the 360 degrees of the circle. So I can say y is going to be 360 minus 64 minus 134 minus 126. 36.
Castleberry, please come to the counseling department. Caleb Castleberry, to the counseling department, please.
The next one is going to be an inscribed quadrilateral. So find the value of x and y. X is going to be found using the property of inscribed quadrilaterals, that opposing angles are supplementary. So 3x plus 105 equals 180. Subtract 105 from both sides. 3x equals 75. So x is going to be 25. The y is going to be found using the fact that y is part of an inscribed angle. So what we're going to say is 2 times that inscribed angle is equal to 2y plus 120, because this is the arc that this inscribed angle intercepts. 2 times 86 is 172, equals 2y plus 120. Subtract 120. 2y equals 52. Divide by 2. Y equals 26 degrees. Number 9, TW and RW are tangent to circle S. The radius is 4, so if I think of radius as being the distance from the edge to the center of the circle, that means that I'm going to draw this here. Note that because it's tangent, it is a right angle, and the radius is 4. Find the measure of angle TWR. So that means TWR, since this is also 16, and this is 4, that means I'm going to have 2 congruent triangles, which means that I need to find the measure of this angle. We'll call this angle x degrees, and then 2 of those are going to be equal to the measure of this, the TWR. So, tangent of x. Now I choose tangent because from this angle, I don't know the hypotenuse, that's WS. I don't know anything about that, so I can't use cosine or sine. Those require the hypotenuse. But I do know the opposite and the adjacent. So x is the inverse tangent of 4 over 16, which of course is 0.25. 4 divided by 16, 0.25, and take the inverse tangent.
Marissa Joe, Marcella Espino, and Kelsey Marshall to the attendance office. Marcella Espino
X equals
and Marissa Joe to the attendance office.
14.0, just about. So times 2 is 28. 28. One, if you're going to want to get really technical, but that's not something I'm going to be so concerned about. 28 because each one of these is 14.0. Number 10, given AB and AC are tangents to the circle. So this is a tangent. That must mean this is a right angle. So I already know 90 degrees is right angle. Since they are both tangent to the circle from the same point, this must be 65. So Z must be 65. That means that I have a 10-degree angle here. So if I've got 10 degrees and 90 degrees, that must mean that this one is 80 degrees because all the angles in a triangle add up to 180. This is going to be 80 degrees. And finally, we're asked to find the radius, and the radius is going to be a side. So since I have one side but not any other sides, I can't use the Pythagorean theorem. I have to use trigonometry. So I'm going to use this one, 10 degrees. I'm going to say that the radius is the opposite, and the 65 is adjacent. So tan of 10 is going to be the opposite radius over 65. So 65 times tan 10, and then take the tangent of that, gives me R equals 65 tan 10. So the radius is going to be 11.5 millimeters. Find the exact value of x in circle H. Okay, so now I'm finding, these are two secants, and I'm finding lengths. So it might be worth noting when you're asked to find a degree measure like this, and when you're asked to find lengths, and sort of sort those things out in your, make sure that they're sorted out in your review, your study guide. Notice that we have a whole bunch with angles. Here I have intersecting chords, and I have something about arcs, but we also have things about lengths here. So in your guide, make sure you have, you're looking at the right column, whether you're talking about line segments and lengths or angles and the measure of arcs. All right, find the exact value of x. So this is TOTO. TO equals TO. Total here is going to be 10 plus x times the outside 10 equals the total 20, because that's what 9 plus 11 is, times the outside 9. So I have 10 times 10 plus x equals 20 times 9, or 180. So this is distributing this. This would be 100 plus 10x equals 180. Subtract 100 from both sides, and I have 10x equals 80. Divide both sides by 10. X equals 8. Similar thing here, but instead of having a total and an outside, we just have two parts. So this is going to be part times part equals part times part. 24x, excuse me, not 24, 14x equals 8 times 21. 8 times 21 is 168. Divide by 14. X equals 12. All right. Last thing is going on to the third page. Here's the third page, number 13. Given MR is tangent to the circle below, find the exact value of x. So we have x is the whole way across. So that's the inside, and here's the outside. So I have, because it's a tangent, I only have an outside. So this is going to be auto. O squared equals T times O. So this is 4.2 squared equals the total x plus 3.5 times the outside 3.5 so 4.2 squared is going to be 17.64, and this is going to be distributed, so we have 3.5x plus 3.5 times 3.5. So subtract 12.25 from both sides. 3.5x equals 17.64 minus 12.25 equals 5.39. Divide by 3.5 and we get 1.54. A truck tire has a radius of 22 inches. I'm going to draw a picture here. 22. Find the exact area, and answer is in terms of pi, then round to the nearest tenth. So area equals pi r squared. So 22 squared is 484. So the exact one is 484 pi. Or 1,520.5. The exact arc length and sector area. So first we need to find the circumference, 2 pi r. So that's 30 pi, right? R is 15. 30 pi. Now I'm not going to calculate this out because it needs to, need to find the exact arc length. So the whole circumference is 30. This is 240, so I need to find the sector area of this. So that means 240 out of 360. That's the same ratio as whatever this area is of the sector. I have been calling it A prime, so I'm going to continue to do that. A prime divided by the, not area of the sector. Oh, I need to find the exact arc length. So I've got two things here to do. Divided by the total area. So area equals pi r squared, which is 225 pi, because 15 squared is 225. So I've got an area and a circumference. Area is the whole everything that fills it in. Circumference is the distance around. In both cases, I'm going to be looking for a part.
Oscar Ward to the attendance office, please. Oscar Ward to the attendance office.
Of a whole. So the sector area is going to be that part divided by 225 pi. The arc length is going to be that length of just that arc over the entire circumference. 24 over 36, 240 over 360, I'm going to reduce this down. This is the same as 24 over 36. You can divide that by 12, and it becomes 2 over 3. So then I have the area equals, I multiply both sides by 225 pi. And I have 225 times 2, 450 divided by 3. So my arc length here, S, oh, that's area, excuse me. Area is 150 pi. And so this is going to be 225 pi times 2 over 3. And that simplifies to 150 pi. And my arc length is going to be, again, this is the same as 2/3. Multiply both by 30 pi. 2 times 30 divided by 3 equals 20. 20 pi. So in both these cases, I'm just working with proportions. If you like to cross multiply, that'll work. I like to just think of I'm solving for the variable on the top, so all I have to do is multiply by the denominator, and that cancels that out. But I just treat the pi like its own thing, like a variable. I don't calculate it out. And then the numbers end up being much simpler to work with in terms of the fraction reduction. Okay, a rotating circular agricultural irrigator has a radius of 150 meters. So I'm just getting you to think about how, like, there are practical applications of this, but we've got a radius of 150 meters. What is the distance that the outer wheel has to travel? In other words, what is the circumference? So 150 is the radius. 2 pi times radius equals 300 pi. So that's the circumference. Find the exact distance in terms of pi and then to the nearest whole. So this is 300 pi. 100 times pi. 942.5. Last ones you're going to be doing are radian measured to degrees. So 2 pi over 3 radians times 360 divided by 2 pi. Remember, I'm trying to cancel out the radians, so that's why I divide by 2 pi, because there are 2 pi radians in a circle. I'm trying to convert to degrees, that's why that's in the numerator. So the 2 pi's cancel out. I'm left with 360 over 3, or 120 degrees. A 225 degree angle. Now we go the opposite direction. So we're flipping the conversion factor. So I've got 225 times 2 equals 450 divided by 360 pi. The zeros cancel out. Now I've got 45 over 36. Both of them are divisible by 9. So this is 5 pi over 4. Extra credit, a security motor has a range of 15, sensor has a range of 15 yards. So here's my sensor. It's got a range of 15. The area covers a 160 degree arc. So this is 160 degrees. So we're saying with a circle of a radius of 15, what is the area that it's going to cover? So I'm going to say the total area of this whole circle is going to be pi r squared, or 225 pi. So 160 out of 225, 160 out of 360 degrees. So it's this portion of the circle out of the whole circle is proportional to the area over the sector over the total area. 16 divided by 36, so those cancel out. Divide each side by 4, and I've got 4 over 9 equals area over 225 pi. So 225, let's see, divided by 3? Yes. Divided by 3. Yes, so 225 divided by 9 equals 25. So 225 times 4 pi over 9. 225 times 4 equals, divided by 9 equals 100. So 100 pi is the area. So this is 100 pi. Now that's square yards. In a square yard, there are 3 feet in each side.
Isabella and Marcelino Vasquez.
So that
to the
means
attendant's office. Isabella
100
and Marcelino Vasquez to the attendant's office.
100 pi square yards, they're going to be 9 square feet in 1 square yard. So that means we're going to multiply by 9. This is going to be 900 pi. In a square foot, there are 12 by 12 square inches, which means we've got 144 square inches. So I'm going to take 900 times 144 equals 129,600 times pi square inches. All right, there's your review. As you can see, there's lots of different formulas to use. That's why it's really important you have your Module 19 study guide sheets all complete and ready to fill it out. I didn't actually show you how to refer to it during this because I had enough practice, but I highly encourage you to make sure this is filled out completely and then you use this while you're practicing. That way you're practicing how do I make sense of this, and that will help you better on the test and help you better internalize it.